So we come on to Konrad Lorenz, who is central in the development of evolutionary epistemology. He was in Königsberg like Kant. He said, "I am a disciple of my old colleague from Königsberg," that is of Kant, and I'm trying to translate his categories into biological terms under the idea of innateness. The cognitive apparatus is itself an objective reality which has acquired its present form through contact with and adaptation to equally real things in the outer world. By the cognitive apparatus, of course, he means essentially the nervous system, the brain, and the complexities of the brain. The spectacles of our modes of thought and perception, such as causality, substance, quality, time, and place, the Kantian categories, are functions of a neurosensory organization that has evolved in the service of survival. What we experience is a real image of reality, albeit an extremely simple one, only just sufficing for our practical purposes. Here I'd slightly question why he says extremely simple, because it seems to me the brain, the powers of the brain are remarkable and contributed to the advance of science and history. Karl Popper, in his book called The World of Parmenides, Essays on the Pre-Socratic Enlightenment, has found in the pre-Socratic support for the kind of views others have advanced about the momentariness of all things. Human experience, he says, does not perceive real life as simply a uniform progression along some imaginary line extended in space, but it's rather a continuous flow. The real world is one of continuous becoming or process. The discreteness is not real. So-called discrete elements are only apparent when we have a need to pluck them from our continuing experience. We may appear to ourselves as things, but we find that we are processes, and he finds impressive empirical evidence of Parmenides' views in the field of quantum mechanics. And so this brings us on to physics. And what is the role of physics? Well, one view is that the great task of physics is to provide as completely as possible a coherent description or a model of all those observations on and in the universe which exhibit a deterministic or causal or repeatable characteristic. Physics, it is said, is not concerned with whether I exist or whether a real world exists beyond my sense perceptions. What physics is concerned with is that part of all observations and knowledge which can be expressed in mathematical terms. But time and space as forms of the understanding, with due and proper acknowledgement to Kant, come before any use physical scientists may make of them. They construct science through using what their consciousness and their awareness provides for them, and they cannot ignore time in that sense. Theories of everything, current theory building in physics to unify gravity and quantum mechanics, is producing fundamental changes in conceptions of time and space. Theories of everything, of course, are far from being realized as yet, but the relation between gravity and quantum mechanics is a central one. At the ultimate so far levels of physics, the identity of particle and wave, or at least the difficulty of distinguishing particle behavior from wave behavior, no longer appears mysterious. Well, this is said, but I'm not so sure that it's the case. There are still mysteries there which have not explicitly been dealt with. A view of Bohm, which I come on to and others, is it is just that without realizing it, we are approaching the final reality of physical existence, the unending play of different patterns within an ultimately stationary material reality, which exists at a scale of magnitude many, many times smaller than anything we have so far been able to approach. I might mention here as a skeptic Julian Barber, who says that even for physicists time does not exist. Time is an illusion. The phenomena from which we deduce its existence are real, but we interpret them wrongly. So this is a question about the role of time in mathematics. The crisis in quantum mechanics has deepened since the discovery by John Bell in 1964 that the collapse mechanism requires us to believe that a measurement in one part of space can result in an instantaneous change of the system in a distant part of space. String theory now is the attempt to grapple with these things. This suggests that fundamental particles are not dimensionless points, but one-dimensional lines. The wiggling superstrings, which were at least vaguely possible to visualize, have now been joined by even more abstract entities, membranes or brains, which are just to say what this means. A two-brain is a two-dimensional surface like a bedsheet stretching across a three-dimensional space. A point is a zero brain, and line a one brain. One can have 3 brains, 4 brains, 5 brains, all the way up to 9 brains, 9-dimensional surfaces inside a 10-dimensional world. Quantum gravity suggests that our world canvas not only has texture, but a foam or sponge-like structure, so that intervals or durations cannot be infinitely subdivided. The space we inhabit, Paul Davies says, takes on the features of a quivering jelly. I don't think that's very helpful. Empty space is not empty. It is the seat of the most violent physics. The electromagnetic field fluctuates. Virtual pairs of positive and negative electrons, in effect, are constantly being created and annihilated, and likewise pairs of mu mesons, pairs of baryons, and pairs of other particles. New Scientist in June 1999 said quantum foam is the fabric of the universe, a seething mass of black holes and wormholes. How come the quantum? How come existence? John Wheeler, very famous physicist, begins and ends his autobiography with this question. Before the second superstring revolution, life was simple. We believed that everything in the universe, quarks, photons, gravitons, electrons, and the rest, were all made out of strings. Now this is where Giddings has, this is a quotation from Giddings. We no longer know what the fundamental constituents of the theory are. Strings and D-branes appear equally fundamental. Perhaps they're all made from something even more fundamental. But the argument continues with no sign of any conclusion. We've made an enormous amount of progress in the past few years, but now the only effect is we realize the greater depth of our ignorance. That's, as I say, a quotation from Stephen Giddings.